Hello friends, today we are going to discuss organic chemistry, some basic principles and techniques. Organic chemistry is the chemistry of carbon compounds except oxides of carbon and metal carbonates. The term organic literally means derived from living organism. All organic compounds containing carbon as their essential constituent. Carbon atom has unique property to form bonds with other carbon atoms. This property of forming bonds with atoms of the same element is called catenation. Carbon form strong bonds with many other elements and especially with other carbon atoms to form chain and rings that gives to rise to million of organic compounds. Classification of organic compounds. Organic compounds are broadly classified in two ways. First, based on carbon skeleton, and second, based on functional group. Now we are going to discuss first, that is based on carbon skeleton. First is aliphatic compounds. These are the compounds in which carbon atoms are joined to form an open chain. Their structure may consist of straight chain or branched chain. Example: CH3, CH2, CH2, CH3. Second is cyclic compounds. These are the compounds in which carbon atoms are joined to form one or more rings. They are further classified into two types, that is homocyclic or carbocyclic, and second is heterocyclic compounds. Homocyclic or carbocyclic compounds. In these compounds, the ring is made up of carbon atoms only. They are further divided into two types: alicyclic compounds or aromatic compounds. Alicyclic compounds are the compounds that shows some of the properties similar to those of aliphatic compounds. Carbon atoms are linked by single bonds only. Example: CH2 bonded with another CH2 bonded with another CH2 bonded with first CH2. So it gives a structure of triangle like. So it is cyclopropane. Another is aromatic compounds. These are the compounds which contains at least one aromatic ring which resembles benzene in their chemical behavior. Example: phenol. Dear friends, it's my humble request that you should visit our website www.chemistrynotesinfo.com, and during listening this lecture, please scroll the website or notes of this chapter so you can also see the structure of the compounds which I dictate in this episode. So let's continue. Another is heterocyclic compounds. These compounds include one or more heteroatoms like oxygen, nitrogen, sulfur, etc. in the ring of carbon atoms. They are also divided into two types, that is heteroalycyclic compounds and heteroaromatic compounds. First is heteroalycyclic compounds. Alicyclic compounds which contain at least one heteroatom in the ring are called heteroalycyclic compounds. Example: tetrahydrofuran THF. Another is heteroaromatic compounds. Aromatic compounds which contain at least one heteroatom in the ring are called heteroaromatic compounds. Example: pyridine. To see structure of pyridine, do visit our website www.chemistrynotesinfo.com. Based on functional group. An atom or a group of atoms in the organic molecule which determines its characteristic chemical properties is called the functional group. I repeat, functional group is a group of an atom or a group of atoms in the organic molecule which determined its characteristic chemical properties is called the functional group. Example: OH, X, CHO, COH, NH2, etc. Means alcohol group, aldehyde group, carboxylic group, amine group, etc. are some examples of functional groups. The chemistry of every organic molecule is determined by the functional group it contains. Homologous series: a series of organic compounds, each containing a characteristic functional group, and the successive members differ from each other in molecule formula by a CH2 methylene group is called homologous series. Purification of organic compounds. The purification of organic compounds involves the following process: crystallization, sublimation, distillation, fractional distillation, steam distillation, fractional crystallization, differential extraction, chromatography. So don't worry, we are going to understand these terminologies. So first is crystallization. This is the most common method used to purify organic solids which dissolve in particular solvent. The purification is done on the basis of differences in solubility of a given organic compound and impurities. Second is sublimation. Sublimation is a process which is used for solids which directly change into vapors state upon heating without passing the liquid state, and vapor on cooling gives back the solid substance. Impure sample of naphthalene, anthracene, camphor, etc. are purified by this method. So, in sublimation, compounds directly change its state from solid state to vapor state, and when it cooled, give back to its solid state. Third one is distillation. The process in which liquid is converted into its vapor phase at its boiling point and the vapor is then condensed back to liquid on cooling is known as distillation. This method is used if the organic liquid is stable at its boiling point and it contains non-volatile impurities. Fractional distillation. The process of separating and purifying the components of a mixture of two or more miscible liquids having different boiling point is known as fractional distillation. The liquids which is more volatile distill out first, leaving behind the less volatile liquid in the distillation flask. Fifth one is steam distillation. Liquids which are immiscible with water but are steam volatile are separated by this technique. Aniline, nitrobenzene, bromobenzene, etc. can be steam distilled. Sixth one is fractional crystallization. The process of separating the components of a mixture of two or more solids having different solubilities in the same solvent at the same temperature by stepwise crystallization is known as fractional crystallization. Seventh is differential extraction. The organic solvents like benzene, chloroform, petroleum, ether, etc. are immiscible with water. Such solvents are used to extract an organic compound present in aqueous solution or by the method of differential extraction. Eighth one is very important, and it is chromatography. Chromatography is the technique used for the separation, isolation, purification and identification of constituents of a mixture. This technique depends on the distribution of the mixture between two phases, one stationary phase and other moving or mobile phase. Depending upon the principle involved, it is divided into two types. First is adsorption chromatography, second is partition chromatography. Adsorption chromatography. Adsorption chromatography is based on the principle of differential adsorption. Different compounds are adsorbed on adsorbent to different degrees. It has two types: column chromatography, thin layer chromatography. Another is partition chromatography. This technique is based on continuous differential partition of components of a mixture between stationary and mobile phase. Determination of empirical formula. The formula of a compound which gives the simple whole number ratio of the atoms of various elements present in one molecule of the compound is called its empirical formula. It involves the following steps. Step first, the percentage composition of elements present in a given compound is determined by quantitative analysis. Step second, the percentage of each element is divided by the respective atomic mass. This gives the atomic ratio of constituents atoms present in a given compound. Step third, the simplest ratio is found by dividing all the atomic ratios by the smallest atomic ratio. Molecular formula. The formula which gives the actual number of atoms of various elements present in one molecule of the compound is called its molecular formula. Molecular formula is determined from empirical formula as molecular formula is equal to n into empirical formula, where n is whole integer given by n is equal to molecular mass divided by empirical formula mass. I repeat, n is equal to molecular mass divided by empirical formula mass. Now we are going to discuss another important topic, that is isomerism. The compounds having same molecular formula and different structural formula are called isomers of each other. This phenomena is known as isomerism. It has two main types: stereoisomerism, structural isomerism. The stereoisomers have the same structural formula but different in arrangement of atoms and groups in spaces. Structural isomerism. The structural isomers differ from each other in the arrangement of the atoms or groups within the molecule. It can be further divided as chain or nuclear isomerism, or positional isomerism, functional isomerism, metamerism. First is chain or nuclear isomerism. It is the type of isomerism in which the isomers differ in the chain of carbon atoms. For example, C4H10 has two isomers, butane or 2-methyl-propane. Second is position isomerism. It is the type of isomerism in which the different isomers differ in the position of the functional groups. For example, C3H7OH has two isomers, propane 1-ol and propane 2-ol. Functional isomerism. It is the type of isomerism in which isomers have different functional group. For example, C2H6O has two isomers, ethanol and methoxymethane. Metamerism. It is the type of isomerism in which the isomers differ in the nature of alkyl group attached to the same functional group. For example, C5H10O has two isomers, diethyl ketone and methyl propyl ketone. Fundamental concepts in organic reaction mechanism. Electron displacements in covalent bonds. Inductive effect. When an organic molecule has a polar covalent bond in its structure, polarity is induced in adjacent carbon-carbon single bond 2. This is called inductive effect. I repeat, when an organic molecule has a polar covalent bond in its structure, polarity is induced in adjacent carbon-carbon single bond 2. This is called inductive effect. The arrow head put in the center of the bond is used to represent the inductive effect. The direction of arrowhead indicates the direction of permanent electron displacement. For example, CH3 arrowhead towards CH2, arrowhead towards CH2, arrowhead towards Cl. So chlorine here is most electronegative element and it's have the charge of delta negative, then its nearest CH2 has delta 1 positive, then delta 2 positive, then CH3 at last is delta 3 positive, where delta 3 positive is lesser than delta 2 positive is lesser than delta 1 positive. This effect decreases rapidly as the length of carbon chain increases. There are two types of inductive effect, minus I effect, plus I effect. Atoms or group of atoms which are highly electronegative or carry positive charge are electron withdrawing groups, and such groups are said to have minus I effect. Example: fluorine, chlorine, bromine, iodine, NO2, CN, COOH, COOR, SO3H, etc. Plus I effect. Atoms or group of atoms which are electropositive and carry negative charge are donating groups and are said to have plus I effect. Example: metals like Na, K, Mg, Zn, etc. and alkyl groups such as CH3, C2, CH2, CH3, CH, CH3, 2, CH3, C2H5, etc. Electromagnetic effect. The complete transference of shared pair of electrons to one of the atom joined by a multiple bond in presence of an attacking reagent. This is known as electromagnetic effect. This is a temporary effect and takes place only in the presence of an attacking reagent. For example, CO plus Cn minus arrowhead CCNO minus. So to actually visualize or see these attacking reagent, visit our website www.chemistrynotesinfo.com, and in 11th class section you see this chapter notes. Another is resonance effect. The polarity developed within a molecule is due to the interaction of two pi bonds or a pi bond with the lone pair of electrons. The present on the adjacent atom is called the resonance effect or mesomeric effect. It is a permanent effect, and depending upon the direction of transfer of electrons, it is of two types: plus R effect, minus R effect. When the transfer of electron is away from an atom or substituent group attached to the conjugated system, it is termed as plus R effect. For example, plus R effect in aniline, minus R effect. When the transfer of electrons is towards the atom or substituent group attached to the conjugated system, it is termed as minus R effect. For example, minus R effect in nitrobenzene. Hyperconjugation. The delocalization of electrons due to overlap between a p orbital and sigma bond of CH is called hyperconjugation or no bond resonance. Greater the number of alkyl groups attached to a positively charged carbon atoms, greater is the hyperconjugation interaction and greater is the stability of cations. Thus, the relative stability of carbon decreases in the order CH3 plus greater than CH3 CH plus greater than CH3 CH2 plus greater than CH3 plus. Bond fission. In any chemical reaction, when a reactant is converted into products, one or more bonds in the reactant are broken and new bonds are formed. The process of breaking or cleavage of covalent bond is known as bond fission. The bond fission takes place in two ways: homolytic fission, heterolytic fission. First is homolytic fission. The symmetrical breaking of a covalent bond between two atoms such that each atom acquires one electron of the shared pair is called homolytic fission or homolysis. Such fission takes place in the presence of ultraviolet light or high temperature. The cleavage of a bond results in the formation of free radicals. A free radical is a neutral species, atoms or groups, which contains an unpaired electron. A homolytic fission is represented as a diagram on our website. So do visit our website. Second one is heterolytic fission. The unsymmetrical breaking of a covalent bond between two atoms such that the more electronegative atom acquires both the electrons of the shared pair is called heterolytic fission or heterolysis. I repeat, the unsymmetrical breaking of a covalent bond between two atoms such that the more electronegative atom acquires both the electrons of the shared pair is called heterolytic fission or heterolysis. Such a fission takes place in the presence of polar solvent. The cleavage of a bond results in the formation of ions. These ions formed are unstable and reactive. One of the ion has a positive charge called as cation, and the other ion has at least one lone pair and a negative charge called as an anion. Organic reactions which proceed by heterolysis are called ionic or heteropolar, simply polar reaction. The species in which carbon atom passes a positive charge is called carbanion, and the species in which carbon atom possesses negative charge is called carbanion. Reaction intermediates. Free radicals. An uncharged species which is electrically neutral and contains a single electron is called free radical. Free radical is highly reactive and therefore has a transitory existence. That is, it is short-lived. The stability of free radicals decreases in the order triphenyl methyl is greater than benzyl, then allyl, then methyl, then vinyl. Carbocations. A species in which carbon atom bear a positive charge is called a carbocation. Positively charged carbon is sp2 hybridized. It is electron deficient. It is Lewis acid and acts as an electrophile. It has planar geometry. Example: tetrabutyl carbocation. Carbanion. A species in which carbon atom bears a negative charge is called carbanion. Negatively charged carbon is sp3 sp2 hybridized. It is electron rich. It is Lewis base and acts as nucleophile. It has pyramidal geometry. Example: methyl carbanion. Carbenes. The highly reactive intermediates containing neutral and divalent carbon atom is called carbene. For example, CH2. Types of attacking reagent: electrophiles, nucleophiles. Electrophiles are electron deficient species. They are either positively charged species like H+, NO2+, etc., or molecules having incomplete octet of electrons like BF3, AlCl3, ZnCl2, etc. Since electrophiles are electron deficient, they accept a pair of electrons from donor atoms and thus they are electron loving reagents. All electrophiles are basically Lewis acids. Nucleophiles. Nucleophiles are electron rich species. They are either negatively charged species like OH-, Cn-, Cl-, Br-, etc., or molecule containing at least lone pair of electron on central atom like H2O, NH3, H2S, ROH, RNH2, etc. Since nucleophiles are electron rich, They donate pair of electrons to acceptor atoms, and thus they are nucleus loving reagents. All nucleophiles are Lewis base. Types of organic reactions: substitution reaction, addition reaction, elimination reaction, rearrangement reactions. First is substitution reaction, a reaction in which an attacking species replaces another atom or group in substrate is called substitution reaction. Example: methane plus Cl2 in presence of ultraviolet light gives methyl chloride plus HCl. Addition reaction: when two molecules combine to form one product molecule, it is called an addition reaction. For example, ethylene plus HCl gives ethyl chloride. Elimination reaction: when one molecule is split into two fragment molecules, it is called an elimination reaction. For example, ethyl chloride in presence of alcoholic NaOH and heat gives ethylene plus HCl. Rearrangement reaction: a reaction in which either the carbon skeleton or the functional group or both are modified is known as rearrangement reactions. Dear friends, you can read these notes from our website www.chemistrynoteinfo.com, or you can join our Telegram channel Chemistry Notes Info to download notes of this chapter. Thank you to learning chemistry with Chemistry Notes Info.